To figure out why the direct substitution of a limit rule exists, let's first draw a function. Let's say the function is f of x equals x. And we can also rewrite this function as y equals x, right? So this is just the function notation and is the same as using this y. Okay, then we're going to draw this coordinate system, x-axis and y-axis. This is y-axis. And to draw this function is pretty simple, right? It's just this is the linear function and it's just a line passing through the origin. Nothing new here. And here's the function f of x equals x. Now, why don't we consider to pick a number on this x-axis? Let's see, right here is 4. And this is corresponding to this point. The x value is 4. The answer is, the question is, what is the y value? You can tell by using this function, since x is 4, so f of x is 4, or y is 4. So here is 4. Nothing new here, right? But let's see this by using the applying the limit. If I approach this 4 on this x-axis from left hand side or the right hand side, what will be the y value? The answer is approaches 4. So the limit is, as x approaches 4, the function approaches 4. So limit of this function as x approaches 4 equals 4. You can see this by some values here. Let's say here's 3. It's getting closer to number 4, but never become 4. But the corresponding y value is getting closer to this 4 as well. So that's why we get this limit. Now, we use this specific value to represent this phenomenon. Why don't we use a variable to write this general form? To do so, similarly, we draw this coordinate system. This is the y-axis, and here's the x-axis. To draw the function and the line passing through the origin, here's the function. Now, instead of picking a number, we just use letter A to represent this x value. And the corresponding y value is just A as well. You can tell by using this function. Since x is A, the function is A as well. Then as the x value approaches the A, the function will approaches A as well. So the limit will be, looks like that. Now, since this function equals x, why don't we rewrite this function? We replace this function with this x, variable x. So limit of x as x approaches A equals A. And this is how you get this direct substitution rule of this limit. It's pretty important because whenever you see this limit of this x or this function, you just directly replace this variable x with this A. For example, let me give you limit of x as x approaches 4. What does that equal? Since we know the direct substitution, we just replace this variable x with this number 4. So the answer is just 4. That's the direct substitution rule. Now, not done yet. We have to learn more about it, right? Let's say if I first give you this limit rules, this limit as x approaches a square bracket. Inside the square bracket, there are two functions and they multiply each other. And we can also simplify for a bit or just rewrite it. And by just distributing this limit inside this bracket, so looks like that. And another bracket, limit as x approaches a, g of x. This is the limit rule. And now consider if I give you this limit as x approaches a, and this time the function have the power of 2. We want to manipulate for a bit, since the power is 2, we can rewrite it as the product of this function. So limit as x approaches a square bracket, where the product of this function times each other. Now, does that similar comparing to this rules? Yes, then we can distribute this limit equals square bracket limit of this function as x approaches a. Similarly, limit. Now, you may see that there are two square brackets, and inside the square brackets, the elements are the same. So we can also rewrite it as equals square bracket limits x approaches a f of x to the power of 2. The main difference is that we put the power for this function, but the last one is we use square bracket enclose all this limit and then to put the this power. So the general form to describe it is, instead of writing a specific number, we use a letter or a variable to represent any number. So to write this general form, limit as x approaches a, and this function to the power of n. And this letter n or variable n can represent any number. So it's equals to this square bracket enclose all the elements and then put this power here. This is pretty important. So now, in the beginning, we derive why do we get this the direct substitution rule. So the general form of it is just limit as x approaches a, and this x equals a. Now, we want to learn more about it. We want to first consider this part, the limit. The limit of x as x approaches a. But this time, I want to put the power and put the power of n. And then we can use this limit rule, which we just derived, to rewrite this limit. So it's also equals to this square bracket, enclose all the elements, and then put the power outside. Then consider the elements inside the square bracket. Does that the same for this thing? Yes. Then we can replace this value with this a, the variable a. So it equals a to the power of n. So we get another important rule. So limit of this x to the power of n as x approaches a equals a to the power n. This is another important rules for the direct substitution. The thing is, the difference is that we have this power here, right? For example, if I give you limit x to the power of 2 as x approaches 3, what does that equal to? So we just use direct substitution, replace this variable x with this number 3. So it's going to be 3 to the power of 2. And simplify it, it will be 9. That's the answer of this limit by using the direct substitution.